Welcome to The Human Brain, Understanding How Our Brain Works, presented by Mindful Literary. This comprehensive guide delves into the intricate world of the human brain, exploring its complex structure, functions, and the remarkable ways it shapes our thoughts, emotions, and behaviors. From the basics of neural communication to the fascinating processes of learning and memory, this book unravels the mysteries of the brain in an accessible and engaging manner. Join us on this journey to discover how our brain works, how it influences our daily lives, and what the future holds for brain research. Chapter 1: Introduction to the Human Brain. Exploring the complexity of the brain. Delve into the intricate web of neural connections that make up our brain. You'll find an astonishing interplay of electrical impulses and chemical signals. Imagine billions of neurons, each with thread-like axons and dendrites, communicating across minute gaps called synapses. The brain's structure is not just a mass of cells, it's a meticulously organized network that facilitates everything we think, feel, and do. Neurons in different regions specialize in specific functions. Our ability to process language, remember faces, or even appreciate art hinges on these specialized regions working together in an elegant harmony. Uncovering the astonishing capabilities and potential of the human brain, we learn that it is remarkably adaptable. This plasticity allows us to learn new skills, form memories, and recover from injuries. The brain's potential for growth and change is a beacon of hope for those facing neurological challenges. Beyond physical recovery, the brain supports our creative and intellectual pursuits, from composing symphonies to solving complex mathematical problems. Our cognitive abilities stem from intricate processes that convert sensory inputs into meaningful experiences, allowing us to navigate the world with precision and creativity. Each discovery about the brain reveals not just its complexity, but its immense potential to shape our lives in profound ways. Considering how interconnected and adaptable our brain is, a practical tip to harness its full potential is to engage in lifelong learning. Whether learning a new language, picking up a musical instrument, or challenging yourself with new puzzles, keeping the brain active and stimulated is key to maintaining its health and enhancing its capabilities. Regular mental exercises can reinforce neural connections, promote brain plasticity, and potentially stave off cognitive decline, ensuring that our most vital organ thrives throughout our lives. Brain structure and function. The human brain is one of the most intricate and fascinating organs in our body, acting as the control center for virtually everything we do. It is divided into several regions, each with its own unique structure and function. One of the primary areas is the cerebrum, which makes up the largest part of the brain. The cerebrum is further divided into two hemispheres, each responsible for different types of cognitive and motor functions. The surface of the cerebrum, known as the cerebral cortex, is what you might picture when you think of the brain's wrinkled appearance, full of folds and grooves that increase its surface area. Beneath the cerebrum lies the cerebellum, a smaller but still crucial part that is primarily involved in coordinating voluntary movements and maintaining balance. Then there's the brainstem, which connects the brain to the spinal cord and controls many automatic functions such as breathing, heart rate, and digestion. The limbic system, including structures like the hippocampus and amygdala, is responsible for emotions, memory, and arousal. Another key player is the diencephalon, which includes the thalamus and hypothalamus and helps regulate functions like temperature, hunger, and sleep cycles. It's incredible how all these parts work together seamlessly to help us function every day. Diving deeper into how these brain regions carry out specific tasks, let's talk about the cerebrum again. It's organized into four lobes: the frontal, parietal, temporal, and occipital. The frontal lobe is like the brain's control panel, managing high-level executive functions such as decision-making, problem-solving, and planning. If you move toward the back, you'll find the parietal lobe, which is essential for processing sensory information like touch, temperature, and pain. The temporal lobe, located on the sides of the brain, plays a pivotal role in processing auditory information and is essential for understanding language and forming memories. Finally, the occipital lobe at the back is the brain's visual processing center, allowing us to interpret and understand the world through sight. The cerebellum, often referred to as the little brain, may be smaller, but its role is substantial. It fine-tunes motor activity, ensuring that our movements are smooth and precise and that we maintain proper balance and posture. The brainstem, simple in appearance, handles an array of critical tasks. For instance, it keeps our heart pumping, our lungs breathing, and our digestive systems functioning without us having to think about it. The limbic system, with its interconnected structures, orchestrates our emotional responses and memory formation. The hippocampus is vital for learning and memory, turning short-term memories into long-term ones. Meanwhile, the amygdala processes emotions such as fear and pleasure. The diencephalon's thalamus acts as a relay station, directing sensory information to the appropriate areas of the brain, while the hypothalamus maintains homeostasis, regulating various bodily functions to keep our internal environment stable. Understanding the brain is not just academic, it's incredibly practical. Knowing that the frontal lobe helps you make decisions can make you appreciate why sometimes you need a moment of quiet to think things through. Realizing that your cerebellum helps with coordination might explain why practice and repetition improve your skills in activities like playing an instrument or sports. Valuing how each part of the brain contributes to who you are can also remind you of the importance of taking care of your brain through good nutrition, mental exercises, and adequate rest. Evolutionary perspective on the brain. The journey of the human brain's evolution is a story as fascinating as it is complex. Starting from the simple neural networks found in primitive sea creatures, the brain has undergone extraordinary transformations over millions of years. Our early ancestors, marine invertebrates, had tiny clusters of nerve cells rather than a centralized brain. These rudimentary neuronal arrangements were sufficient for basic survival tasks, like sensing the environment and responding to threats or opportunities. As life forms ventured onto land and grew more complex, so did their neural machinery. Reptiles, for instance, developed a more organized brain structure to regulate increasingly intricate behaviors. When mammals emerged, a significant leap in brain development occurred. These creatures required advanced sensory processing, motor coordination, and social interaction capabilities. The brain started to exhibit complex layering and specialization in its various regions. Specific areas became dedicated to functions like hearing, vision, and problem solving. The neocortex, a hallmark of the mammalian brain, expanded dramatically. This allowed for higher order functions, setting the foundation for memory, reasoning, and language, traits that would eventually become profoundly evident in human evolution. Crucially, these advancements were driven by ecological demands and social complexities that necessitated smarter, more adaptable brains. A key turning point was the human lineage's split from other primates about 6 to 7 million years ago. Significant changes began to shape our ancestors' brains, partly driven by the need to navigate their environments and forge social bonds. The arrival of the Homo genus saw an accelerated pace of cranial expansion. With Homo sapiens, the brain reached proportions that dwarfed those of our predecessors. These changes weren't merely about size. They entailed an intricate reorganization of brain circuits, enhancing cognitive flexibility, emotional regulation, and planning capabilities. Essentially, this evolutionary tale teaches us that the brain didn't evolve in isolation. It was, and still is, deeply intertwined with the physical and social environments experienced by our forebears. Chapter 2: Neurons and Neural Communication. The role of neurons in brain function. Neurons are the fundamental building blocks of the brain, making up the core of its complex architecture. Imagine an intricate labyrinth of tiny, interconnected circuits. Each circuit or neuron plays a crucial role in how we think, feel, and move. These microscopic cells, about 100 billion of them, form the basis of our brain's structure and are essential for all its functions. The unique beauty of neurons lies in their specialized ability to transmit information rapidly and precisely across vast networks. Structurally, a neuron comprises three main parts: the cell body, dendrites, and an axon. The cell body, or soma, houses the nucleus and serves as the neuron's control center. Dendrites are branching extensions that receive signals from other neurons and convey them to the cell body. The axon, a long singular projection, carries these signals away from the cell body to other neurons, muscles, or glands. This fascinating design allows neurons to process and transmit information with extraordinary efficiency, forming the basis of everything from simple reflexes to intricate thoughts and emotions. The magic of brain function truly begins when neurons communicate, forming an extraordinary network capable of performing complex tasks. Neurons communicate through a process known as synaptic transmission, which involves electrical and chemical signals. When a neuron receives a signal, an electrical impulse called an action potential travels down the axon to the synapse, the junction between neurons. At the synapse, the electrical signal triggers the release of neurotransmitters, chemical messengers that cross the gap between neurons. These neurotransmitters bind to receptors on the dendrites of neighboring neurons, initiating a new electrical impulse in the receiving neuron. This elegant dance of electrical and chemical signals allows neurons to transmit messages rapidly across the brain's vast network. Moreover, neurons can form vast networks through synapses, with each neuron potentially connecting to thousands of others. This interconnectedness underpins the brain's remarkable capacity for parallel processing and adaptability, enabling learning, memory, and nuanced responses to the environment. Understanding the role of neurons in brain function sheds light on the incredible complexity and efficiency of the nervous system. By appreciating how these tiny cells work together, we gain insight into the very essence of what makes us human: our thoughts, emotions, and actions. The study of neurons and their networks not only helps us comprehend basic brain functions, but also paves the way for advancements in treating neurological disorders and mental health conditions. Understanding neural networks. Diving deeper into the intricate networks that enable brain function, imagine your brain as a bustling city where millions of streets interconnect, each teeming with traffic. These streets are akin to our neurons, the nerve cells that form the core components of our nervous system. Neurons communicate with each other through synapses, creating a web of connections that transport information across different parts of the brain. This network is pivotal for everything we do, from simple reflexes to complex thoughts. To better understand this, consider each neuron a participant in a grand symphony, each playing a unique role but seamlessly coordinating to produce a harmonious outcome. When it comes to exploring how neural networks process and relay information, the process can be likened to a relay race. Information, in the form of electrical impulses, travels along neurons through axons, long, thread-like extensions. Upon reaching the synapse, these impulses trigger the release of neurotransmitters, the chemical messengers that cross the synaptic gap to the next neuron. This chemical electric signal conversion speeds up or slows down signals, allowing the nervous system to fine-tune responses. Neuroplasticity, the capacity to rewire based on experiences, ensures the network's adaptability and robustness. Think of it as having a road that can not only evolve its pathways, but also expands its network, ensuring efficient traffic flow and handling unexpected jams. Neurotransmitters and their effect on behavior. Our brain is a bustling hub of communication, where countless messages are passed around via chemical messengers known as neurotransmitters. Imagine tiny parcels being delivered all over your brain, each one carrying crucial information that shapes our thoughts, emotions, and behaviors. These microscopic messengers are produced by neurons and are released into the synapse, the gap between neurons, where they are picked up by neighboring neurons. It's a delicate dance that happens at lightning speed, allowing us to process information, feel emotions, and react to the world around us. I remember vividly the first time I truly grasped the importance of neurotransmitters. A close friend of mine, always the life of the party, started withdrawing socially. It was perplexing until they were diagnosed with depression and explained how an imbalance in serotonin levels was affecting their mood. Serotonin, often dubbed the feel-good neurotransmitter, plays a crucial role in regulating mood, sleep, and appetite. When levels are off-kilter, it can lead to a host of emotional and physical symptoms. Dopamine is another key player, often associated with pleasure and reward. Think about the thrill of acing an exam or the satisfaction of a delicious meal. That's dopamine at work. However, its influence isn't all about joy. Imbalances in dopamine levels have been linked to serious conditions like Parkinson's disease and schizophrenia, influencing everything from motor control to complex behaviors and emotions. The intricate relationship between neurotransmitters and our behaviors emphasizes how finely tuned our brain chemistry must be to maintain mental health. Neurotransmitter imbalances can sometimes spiral into significant psychological disorders. Anxiety disorders, for instance, have been connected to abnormalities in neurotransmitter systems, such as an excess of norepinephrine or a deficiency in gamma aminobutyric acid, GABA. Picture being in a constant state of fight or flight, jittery, on edge, and overwhelmed. These feelings are familiar to individuals with anxiety disorders, often driven by an excess of norepinephrine, which primes the body for emergency action. For those battling depression, it's often not just about feeling sad, but a pervasive sense of hopelessness and lethargy, which can be traced back to deficiencies in neurotransmitters like serotonin and dopamine. Schizophrenia, on the other hand, is a complex disorder thought to be influenced by multiple neurotransmitter systems, including dopamine and glutamate. This leads to symptoms that drastically alter one's perception of reality, triggering hallucinations, delusions, and cognitive difficulties. The intricacies of neurotransmitters and their effects on our behavior underscore the importance of maintaining a balanced brain chemistry. It's fascinating, albeit a bit sobering, to realize just how much our mental well-being hinges on these tiny chemical communicators. Awareness and understanding of this can inspire better mental health practices and hopefully more empathy for those struggling with psychological disorders. Chapter 3: Sensory Processing and Perception. The neural basis of sensory processing. Ever wondered what happens in our brain when we see, hear, touch, taste, or smell something? Our brain is a marvel at interpreting and processing sensory information from the environment, transforming raw signals into meaningful experiences. It starts with sensory receptors, specialized cells that detect stimuli. For instance, when light enters our eyes, photoreceptors in the retina convert light into electrical signals. These signals travel to the brain's visual cortex, where they are processed to create the images we see. Each sense follows a similar path. Sensory receptors capture the initial data, and neural pathways transmit this information to the brain, where it is decoded and interpreted. Interestingly, different sensory systems contribute in unique but interconnected ways to our perception of the world. Our senses don't function in isolation. They work together to provide a coherent understanding of our surroundings. For example, the auditory system processes sound waves through the cochlea in our ears, sending signals to the auditory cortex. However, context and prior experience, often sourced from vision and touch, enhance our ability to locate and interpret these sounds. Similarly, our sense of smell and taste are closely linked. Flavors perceived by our taste buds are significantly influenced by the olfactory input from our nose. This multisensory integration allows for more nuanced and accurate perceptions, enabling us to navigate and interact with our environment effectively. Next time you bite into a juicy apple, notice how the taste isn't just about flavor, but also involves the crisp sound, the aroma, and the feel of the fruit in your hand. Understanding how sensory systems converge can enrich our appreciation for these everyday experiences. Consider paying attention to a particular sense in different contexts throughout your week. Notice the variations and overlaps, whether it's the sound of rain, the smell of coffee, or the feel of a soft blanket. This mindful engagement with our senses opens up a fascinating view into the complexities of our neural processing and brings us closer to the intricate and beautiful ways our brain makes sense of the world. Perception and reality. It's fascinating how our perception shapes our understanding of reality. When I think about it, the interplay between what we perceive and what is actually out there forms the cornerstone of our experiences. We often take for granted that what we see, hear, and feel is an accurate reflection of the world. However, the relationship between perception and reality is more complex than it appears on the surface. Our sensory experiences are influenced by numerous factors such as expectations, prior knowledge, and even the context in which we find ourselves. These factors can sometimes lead to a distorted understanding of reality. For instance, have you ever mistaken a shadow for a person in a dimly lit room? This common experience underscores how perception can differ from reality. Diving deeper into this topic, it is astonishing to discover how our brain constructs our perception of the world around us. The brain doesn't just passively receive information, it actively interprets sensory input to create a coherent picture of our surroundings. This process involves a complex interplay of neurons and cognitive functions. For example, when light enters our eyes, it is transformed into electrical signals that travel to the brain. Here, the brain combines this raw data with previous knowledge and contextual information to generate what we ultimately perceive as our visual reality. This constructed perception is not always a mirror image of the external world, but rather a subjective representation that helps us navigate it effectively. One intriguing aspect of perception is how it can be manipulated and sometimes deceived. Optical illusions are a perfect example of this. These visual tricks exploit the brain's tendencies and shortcuts in processing visual information, revealing some of the underlying mechanisms that guide perception. Understanding these mechanisms can offer profound insights into how we interact with the world and make informed decisions based on our sensory experiences. For example, knowing that our brain fills in gaps in visual information can help us be more mindful of jumping to conclusions based on incomplete data. Disorders of perception and sensory processing. Imagine waking up one day and the world around you feels distorted. The sounds you used to enjoy now seem unbearably loud, or the touch of your clothes feels like sandpaper against your skin. These experiences are common for people with disorders of perception and sensory processing. These disorders occur when the brain incorrectly processes sensory information, mixing up sights, sounds, smells, tastes, and touch sensations. They can be congenital or acquired through injury or illness. Understanding the neurological basis of these disorders involves delving into how the brain perceives, organizes, and responds to sensory inputs. The thalamus, a vital brain structure, acts as a relay station, directing sensory data to appropriate areas of the cortex. When this pathway malfunctions, it can result in symptoms such as hypersensitivity, perceptual distortions, or complete sensory neglect. Living with these disorders can be likened to navigating a world where the usual rules no longer apply. Simple activities such as grocery shopping or attending a social gathering become overwhelming due to sensory overload. Individuals often describe a feeling of being bombarded by a cacophony of stimuli, making concentration and interaction difficult. In children, such as those on the autism spectrum, these disorders might manifest as extreme reactions to textures or sounds, causing distress and social isolation. Adults might struggle with tasks that require sustained attention, leading to professional and interpersonal challenges. Engaging with sensory processing disorders in daily life requires creative coping strategies like using noise-canceling headphones, creating calm environments, or relying on structured routines to mitigate unexpected sensory inputs. These adaptations help individuals maintain a semblance of normalcy despite their heightened or dulled perceptions. Chapter 4. Learning and Memory. Neurobiology of learning. Learning is one of the brain's most fascinating capabilities. When we encounter new information, there's a cascade of events happening inside our heads. Essentially, our brain's structure and functioning start to change. Neurons, the cells in our brain, form new connections through tiny junctions called synapses. These synapses are dynamic and constantly evolving, allowing for the formation and strengthening of neural networks that represent new knowledge and skills. When I dive into learning something new, I can almost feel my brain stretching and adapting, forging new paths and connections. It's like watching a complex puzzle gradually come together. Delving deeper into the mechanics, we can see that different types of learning utilize various neural pathways. For instance, when I learn to ride a bike, procedural memory engages my brain's motor and sensory motor networks. This type of learning depends heavily on practice and repetition, reinforcing the synapses involved in muscle movements and coordination. On the other hand, when I memorize a friend's phone number, declarative memory is at play, mainly involving the hippocampus and other parts of the medial temporal lobe. Each kind of learning has distinct neural underpinnings, demonstrating the brain's incredible capacity to adapt and specialize based on the information it processes. Memory formation and storage. Memory formation and the brain's ability to store information is a marvel of nature, often compared to the most advanced computers, yet far surpassing them in complexity and efficiency. It always amazes me how a simple walk in a park, a familiar tune, or the smell of freshly baked bread can trigger vivid memories, sometimes from decades ago. Have you ever wondered what happens in our brains to make this possible? Our brains constantly weave threads of experiences into the intricate fabric of our personal histories. Each memory starts as a moment that the brain perceives and decides is worth keeping. The journey of a memory begins with encoding. This is when our brains convert the information we sense, like the laugh of a friend or the taste of chocolate, into a form that can be stored. Think of this step as taking a photograph. This encoding process is influenced by attention, meaning memories linked to strong emotions or significant events are often better encoded. Once information is encoded, it needs to be consolidated, involving the stabilization of a memory trace after its initial acquisition. This consolidation is like developing the photograph. It is when the brain processes and organizes the information for long-term storage during rest periods or sleep. Next, we encounter retrieval, which acts as the brain's search engine, efficiently sifting through stored memories to bring relevant information back to our consciousness. Sometimes this retrieval process can be instantaneous. Other times, we might find ourselves on the tip of the tongue phenomenon, deeply embedded in the rich tapestry of neural connections that define our understanding of the world. Our brain's capacity to form and store memories is not only fascinating, but also deeply practical. Understanding these processes can improve how we approach learning new skills or studying for examinations. For example, actively engaging with material through spaced repetition and varied practice can enhance encoding and consolidation, turning fleeting impressions into lasting knowledge chunks. Paying attention to emotional states during learning can also be beneficial, as emotionally charged experiences are often more memorable. Cultivating good sleep hygiene is another simple but powerful way of aiding consolidation. It might seem surprising that something as ordinary as sleep can have such a profound effect on memory. Yet during those hours of rest, our brains work tirelessly to sort, categorize, and strengthen our memories, readying them for future retrieval when we need them most. The impact of emotions on memory. Have you ever wondered why certain memories stick with us so vividly, while others seem to fade away? It turns out that emotions play a crucial role in how our memories are formed, stored, and recalled. The relationship between emotions and memory processes in the brain is complex but fascinating. When we experience strong emotions, the brain releases chemicals like adrenaline and cortisol, which enhance the storage of those moments. These chemicals act on the amygdala and hippocampus, regions of the brain involved in emotional regulation and memory formation, respectively. What is particularly interesting is how these emotional memories can become so deeply ingrained in our minds that they influence our perceptions and reactions to new experiences. Emotional experiences have a unique ability to shape the way we remember events. For instance, think about a particularly happy or sad moment in your life. Chances are, you remember it in great detail, from the sights and sounds to the emotions you felt at that time. This happens because emotional events are processed differently by the brain compared to neutral events. They are given priority, making them more likely to be encoded into long-term memory. Additionally, when we recall these emotional memories, the same regions of the brain are activated, which can make the recall itself an emotional experience. This serves a practical purpose, as it helps us learn from past experiences and apply that knowledge to future situations. A helpful tip I have found is to leverage this relationship between emotions and memory in daily life. For instance, if you are studying for a test or trying to remember important information, try to associate the material with an emotion. It could be excitement, curiosity, or even a personal connection to the topic. By doing this, you are more likely to remember the information later because your brain is wired to prioritize emotionally charged memories. This simple strategy can make a significant difference in how effectively you retain and recall information. Chapter 5. Consciousness and unconscious processes. Conscious versus unconscious decision making. Every single day, we all make countless decisions, big and small. Whether it's choosing what to eat for breakfast or deciding on a major career move, both conscious and unconscious processes play a role in these choices. Conscious decision making is something most of us are familiar with. It involves actively thinking, analyzing, and weighing options before making a choice. We engage in this type of decision making when the stakes are high or when we encounter new and complex situations where existing habits and instincts may not apply. In these circumstances, we take the time to deliberate and consider our options carefully. However, a significant number of our decisions are made unconsciously. These decisions happen quickly and without deliberate thought, often based on our past experiences, emotions, and ingrained habits. This process is incredibly efficient, allowing us to perform routine tasks and make snap judgments without constantly overloading our cognitive resources. For example, when driving a familiar route, much of what we do is on autopilot. Braking, steering, and changing lanes are actions governed by our unconscious mind. What's fascinating is how our unconscious mind often reaches conclusions faster than our conscious mind, providing us with intuitive feelings or gut reactions that can guide our behavior, sometimes before we're even fully aware of what's happening. Automatic processes are those quick, instinctual responses that we develop over time. These are often influenced by heuristics, mental shortcuts that help us navigate complex environments without getting bogged down by every detail. While highly efficient, these processes can sometimes lead us to biased or suboptimal decisions. On the other hand, deliberate processes require conscious effort and involve weighing pros and cons, seeking out information, and reflecting on potential outcomes. Deliberate decision-making is particularly useful in scenarios that are novel or complex, where relying on automatic responses might lead us astray. That said, blending automatic and deliberate processes can often yield the best results, allowing us to benefit from both speed and accuracy. The brain's role in human consciousness. Consciousness is one of the most fascinating and complex phenomena we encounter. At its core, consciousness refers to our individual awareness of our own thoughts, memories, feelings, sensations, and environments. But what about the brain gives rise to this rich tapestry of experience? Neuroscientists have been probing the neural mechanisms underlying consciousness and self-awareness for decades, employing cutting-edge technology to get closer to answers. The cerebral cortex, especially the prefrontal cortex, is known to play a crucial role. This front part of the brain is involved in complex cognitive behavior, decision-making, and moderating social behavior, all key to self-awareness. Functional MRI scans reveal that regions like the default mode network, which includes the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, become active when we engage in introspective thinking or daydreaming. Another critical component is the thalamus, often described as the brain's relay station, which filters and coordinates sensory information. Without this intricate structure, sensory information would overwhelm us, making focused, coherent consciousness almost impossible. Scientific research on the nature of consciousness is ongoing, and it moves at a rapid pace. Researchers are continually making groundbreaking discoveries that challenge our existing paradigms. One intriguing concept is the integrated information theory, IIT, which posits that consciousness arises when information is integrated in the brain to form a unified whole. This theory suggests that consciousness isn't limited to humans, but could exist in any system that possesses sufficient complexity and integrated information. On a different front, some scientists are delving into the quantum mind theories, hypothesizing that quantum mechanical processes in the brain's microtubules might be the source of consciousness. Though still controversial and not universally accepted, quantum approaches add an exciting dimension to the debate. Moreover, advancements in artificial intelligence push us to rethink the nature of consciousness. Could a sufficiently advanced AI become self-aware? Initiatives like the Human Brain Project and Brain Initiative aim to map the brain in unprecedented detail, giving us tools to further probe the depths of our mind. The implications of these studies are not just academic. understanding consciousness can profoundly impact mental health treatments and our understanding of the human condition itself. The power of the subconscious mind. The subconscious mind is a powerful tool that influences our daily thoughts and actions in ways we often don't realize. Imagine times you've acted on a hunch, made snap decisions, or had sudden insights. These are moments when your subconscious mind is at play. It works behind the scenes, processing an immense amount of information, forming patterns, and shaping your perceptions. The capabilities of the subconscious are vast, affecting everything from your habits and routines to how you perceive success and failure. By understanding and tapping into its power, we can reframe negative beliefs, build confidence, and improve overall well-being. What's fascinating about the subconscious mind is how it handles information outside our conscious awareness. While we may be aware of a few stimuli in any given moment, our subconscious is busy processing thousands of data points from our environment. It deciphers the tone of a conversation, remembers the route to work, and even triggers feelings based on past experiences, all without us needing to actively think about it. This ability to absorb and interpret information effortlessly helps us navigate the world more efficiently. But it also means that subconscious beliefs, whether positive or negative, can steer our decisions and actions, sometimes without us even realizing it. To harness the power of your subconscious, start by paying attention to your inner dialogues and recurring thoughts. Are they positive and supportive, or do they tend toward the negative? Simple practices like positive affirmations and visualization techniques can begin to shift your subconscious programming. Over time, these small changes can lead to significant improvements in how you approach challenges and opportunities. Recognizing the impact of your subconscious and actively engaging with it can open up new pathways to personal growth and self-improvement. Chapter 6: Emotions in the Brain. Neurological basis of emotions. Emotions, those vivid and sometimes overwhelming experiences, are not just abstract feelings but are deeply rooted in the neural mechanisms of our brain. When we feel joy, sadness, anger, or fear, a cascade of neural processes is set in motion. Imagine a beautiful symphony orchestra where each musician plays a vital role in creating a harmonious piece. Similarly, our brain orchestrates emotions through a network of neurons, neural circuits, and neurotransmitters. This complex machinery involves various areas of the brain that work together to generate and regulate our emotional experiences. One key player in the emotional symphony is the amygdala, a small almond-shaped structure deep within the temporal lobe. The amygdala is like the conductor, responsible for detecting emotional significance and triggering necessary responses. When we encounter something that could be a threat, the amygdala responds rapidly, even before we consciously recognize it. This quick action helps us react swiftly to danger, initiating the fight or flight response. The prefrontal cortex, on the other hand, serves as the rational counterpart to the amygdala. It helps us modulate our emotions, allowing us to think before we act and to regulate our emotional responses appropriately. It's as though the prefrontal cortex acts as the wise advisor, guiding the emotional conductor. Neurotransmitters, the chemical messengers in our brain, also play a crucial role in the experience and regulation of emotions. Dopamine, often dubbed the feel-good neurotransmitter, is associated with reward and pleasure. When we do something enjoyable, dopamine levels surge, making us feel happy and motivated. Serotonin, another important neurotransmitter, contributes to mood regulation. Low levels of serotonin are linked to depression and mood disorders, while balanced levels promote feelings of well-being and stability. Additionally, norepinephrine, known for its role in the body's stress response, heightens alertness and arousal, preparing us to face challenges. Understanding the neural basis of emotions helps in comprehensively grasping how we feel and why we react in certain ways. By recognizing the intricate interplay between different brain regions and neurotransmitters, we gain insights into our emotional lives. This knowledge can empower us to better manage our emotions, fostering healthier and more balanced lives. Next time you feel a rush of emotion, whether it's elation, sorrow, or anger, remember that there's a complex yet fascinating dance happening in your brain, guiding you through the rich tapestry of human experience. Emotional regulation and mental health. Exploring strategies and mechanisms for regulating emotions in the brain forms the foundation of understanding our overall mental well being. Emotional regulation involves complex processes that the brain uses to manage and respond to emotional experiences. It's surprising how much of this happens without our conscious awareness. The prefrontal cortex, for instance, plays a significant role by helping us think rationally, suppress impulsive reactions, and plan suitable responses. Cognitive reappraisal is one effective strategy where one changes the interpretation of an emotional trigger. For instance, viewing an unexpected job loss as an opportunity for growth instead of a devastating failure can trigger a completely different emotional response. Mindfulness practices have also shown to be powerful tools in regulating emotions. By staying present and fully engaging with the current moment, mindfulness helps reduce the grip of overwhelming emotional experiences. It's fascinating how techniques like deep breathing and meditation can activate the parasympathetic nervous system, promoting calmness and reducing stress. Moreover, social support significantly impacts our ability to regulate emotions. Simply talking to a trusted friend or therapist can provide perspectives and coping strategies that we might not see on our own. Examining the link between emotional dysregulation and mental health disorders reveals the profound impact our emotional control, or lack thereof, can have on our lives. When we struggle to manage our emotions effectively, it can lead to a variety of mental health issues. For example, chronic stress and anxiety often stem from persistent emotional dysregulation. Individuals might swing between emotional highs and lows, experiencing intense sadness or anger that seems disproportionate to the situation. Major depressive disorder, bipolar disorder, and borderline personality disorder are some of the conditions closely associated with emotional dysregulation. People with these disorders may find it incredibly challenging to soothe their distressing emotions, leading to coping mechanisms that might be harmful, such as substance abuse or self-harm. Understanding this link is crucial because it underscores the importance of developing and practicing emotional regulation skills to maintain mental health. One actionable tip is to practice identifying emotions as they occur. Labeling emotions, acknowledging that you're feeling sad, angry, or anxious, can lessen their intensity and start the process of managing them effectively. It's a simple step, but can be remarkably empowering in the journey towards better emotional regulation and mental health. Impact of stress on brain function. Stress leaves an extensive footprint on our brain's structure and function. When I look back at times I felt the weight of the world on my shoulders, I can almost relive the moments of mental fog, headaches, and fatigue that accompanied those stressful periods. This led me to dig deeper into what stress does to the very machinery of our brain. It turns out stress impacts several critical brain regions, including the hippocampus, amygdala, and prefrontal cortex. The hippocampus, involved in forming new memories and learning, shrinks under prolonged stress. This structural change explains why, when we're stressed, recalling information or learning something new feels like climbing a steep hill. Then there's the amygdala, the brain's fear center that becomes hyperactive under stress, making us more prone to anxiety and aggression. Equally troubling is the prefrontal cortex, responsible for decision-making, social behavior, and personality expression. Chronic stress weakens this area, leading to poor judgment and impulsive actions. Essentially, stress hijacks our brain, prioritizing short-term survival over long-term thinking and well-being. Equally concerning is the relationship between chronic stress and mental health disorders. Everyday stress might be manageable, but when it turns chronic, it becomes a breeding ground for disorders such as depression and anxiety. Persistent stress hormones, especially cortisol, wreak havoc by disrupting the delicate balance of neurotransmitters like serotonin and dopamine. This imbalance accounts for feelings of sadness, hopelessness, and the pervasive sense of worry common in mental health disorders. From my own experiences, living under constant stress felt like walking in a fog where everything was fractured and heavy. It wasn't just in my head. Scientific evidence supports that chronic stress essentially rewires the brain. Over time, these changes make it tougher to bounce back from adversity, locking us into cycles of negative thinking and heightened reactivity. Understanding this connection is key in addressing not just the symptoms, but also the root cause of many mental health issues. One thing that has made a world of difference for me, and could for anyone dealing with stress, is practicing mindfulness. By taking just a few minutes each day to breathe deeply, meditate, or simply focus on the present, we can reset the brain's stress response, leading to better function and overall well-being. It's not about eliminating stress altogether, but managing it in ways that keep our brain healthy and resilient. Chapter 7: Language and the Brain. Neurobiology of Language Processing. When we think about how our brains process language, it's astonishing to witness the complexity and efficiency involved. Language processing involves multiple brain regions, each contributing its part to understanding and producing speech. The left hemisphere is typically the most active in language processing, specifically areas like Broca's area, responsible for speech production, and Wernicke's area, crucial for language comprehension. These areas are interconnected through a bundle of nerve fibers known as the arcuate fasciculus, enabling the seamless flow of information necessary for fluent communication. The act of processing language begins even before words are spoken. Our auditory cortex picks up sounds from the environment. It filters out irrelevant noises and focuses on sounds that form language. This information is then relayed to Wernicke's area, where it's transformed into meaningful words and sentences. During a conversation, Broca's area gets activated to help us formulate grammatically correct and contextually appropriate responses quickly. This interplay enables us to engage in a fluid and meaningful dialogue without conscious effort. Delving into language acquisition and comprehension from a neural perspective opens up another fascinating chapter of the brain's capabilities. From birth, infants are exposed to a plethora of sounds that gradually get shaped into meaningful language through interaction and repetition. During this crucial period, the brain exhibits a significant degree of plasticity, allowing it to form and rewire connections rapidly in response to linguistic input. Studies have shown that babies can distinguish between different phonetic sounds even before they start speaking, highlighting an innate preparedness for language learning. As we grow, our neural pathways become more specialized, fine-tuning our ability to understand and produce complex language structures. Learning a language triggers activity not only in Broca's and Wernicke's areas, but also engages the hippocampus for memory storage and the motor cortex for speech articulation. This comprehensive neural involvement ensures that we can remember vocabulary, master syntax, and articulate words correctly. Importantly, the flexibility of these neural mechanisms allows the acquisition of multiple languages, demonstrating the brain's remarkable adaptability. Understanding the intricate ways our brain processes and comprehends language can provide us with practical strategies for improving communication skills. For instance, engaging in regular conversation, enriching our vocabulary, and practicing new languages can stimulate these neural networks, keeping them sharp and responsive. This insight encourages us to continually challenge our brain with linguistic tasks, ensuring that language processing remains efficient throughout our lives. Bilingualism and brain development. When I first learned about the cognitive benefits of bilingualism, I was both intrigued and skeptical. The idea that juggling two languages could actually enhance brain development sounded almost too good to be true. Yet, numerous studies have shown precisely that. Bilingual individuals often display superior cognitive flexibility, meaning they are better at adapting to new situations. This flexibility stems from the constant exercise the brain gets through the process of switching between languages, a mental workout that monolinguals don't experience as intensively. It's fascinating to think that bilingualism could help delay the onset of Alzheimer's disease and other forms of dementia. The brain regions involved in executive functions, such as the prefrontal cortex and the anterior cingulate cortex, are particularly stimulated, essentially becoming more robust through the habitual practice of managing two language systems. Have you ever watched someone seamlessly switch between two languages and wondered what's going on inside their head? The process is far from simple. Bilingual individuals constantly monitor their environment to choose the appropriate language, activating both languages simultaneously before selecting one in context. This constant balancing act strengthens the brain's ability to concentrate, filter out irrelevant information, and make decisions quickly. The phenomenon known as code switching, where a person alternates between two languages within a single conversation, showcases the brain's remarkable adaptability. Neuroimaging studies reveal that areas like the dorsolateral prefrontal cortex light up during language switching, providing evidence of the high-level executive control involved. What's even more amazing is that bilinguals are generally better at multitasking and exhibit higher cognitive reserve, suggesting their brains are wired to handle multiple streams of information more efficiently. So there you have it. Bilingualism does more than just equip you with an additional language. It serves as a mental workout that sharpens cognitive abilities and fortifies the brain against age-related decline. If you're considering learning a new language, think of it as a long-term investment in your brain health. Dive into books, watch movies, or chat with native speakers. The benefits are as boundless as the worlds that each language opens up for you. Language disorders and neurological implications. Language disorders often have a deeply rooted neurological basis, which can make understanding and communicating extraordinarily challenging for those affected. When delving into the intricacies of the brain, it's fascinating how specific regions are responsible for our ability to comprehend and produce language. Often, damage to areas such as Broca's area can result in expressive language issues, while damage to Wernicke's area affects receptive language skills. These areas, located in the left hemisphere of the brain, play a crucial role in enabling us to understand and speak effectively. The complexity of neural connections involved means that even a minor injury or abnormality can lead to significant language impairments. Understanding this neurological framework helps medical professionals develop better treatment and intervention strategies tailored to individuals' needs. The consequences of language deficits extend far beyond mere communication challenges. For individuals suffering from these impairments, social interactions can become a battleground of frustration and isolation. Imagine not being able to express your thoughts clearly or failing to understand what others say. This creates a barrier, distancing one from social engagements and relationships. Cognitive functioning, too, takes a hit as language is intricately linked with thought processes. Think about how we often talk to ourselves in our minds to solve problems or retain information. For those with language disorders, this internal dialogue can be disrupted, leading to difficulties in learning and memory. These challenges often result in lower academic achievements and limited job opportunities, further impacting the individual's quality of life. Supporting these individuals not only involves language therapy, but also creating an inclusive environment that acknowledges and mitigates their struggles. Chapter 8. Motor Control and Coordination. The brain's role in movement. I find it endlessly fascinating how the brain orchestrates the complex ballet of movement we often take for granted. Each time we decide to pick up a cup of coffee or even breathe without thinking, our brain is at the helm, orchestrating every detail precisely. Voluntary movements, like waving a hand or stepping forward, are intentionally initiated. Our brain assesses the situation, plans the action, and sends signals through neural pathways to activate the necessary muscles. Involuntary movements, such as the beating of the heart or reflex actions, are controlled automatically by different brain regions and pathways, ensuring our bodies function smoothly even when we're not consciously aware of them. The structures involved in motor control read like a well-rehearsed ensemble cast. The primary motor cortex in the cerebrum initiates voluntary movements by sending signals through the spinal cord to the muscles. The cerebellum refines these movements, ensuring precision and coordination. Meanwhile, the basal ganglia regulate movements, filtering the commands from the primary motor cortex and ensuring the right amount of force is used. The brainstem contributes by controlling the finer aspects of movement, such as balance and posture, and it's deeply involved in the involuntary movements that keep us alive. These intricate pathways and structures work in harmony, constantly communicating with each other to produce fluid movements and respond to changes both inside and outside the body. Neurological basis of motor skills. The process of acquiring and mastering motor skills is a fascinating voyage through the complex networks of our nervous system. At the core of this journey is our brain's ability to integrate sensory inputs, plan movements, and execute complex motor tasks. The primary motor cortex, residing in the frontal lobe, serves as the command center for voluntary movements. This region sends signals through the spinal cord to the muscles, facilitating actions ranging from simple gestures to intricate athletic feats. Motor skills, whether learned during early childhood or honed through deliberate practice in adulthood, rely on this precise coordination of neurons. The brain's flexibility, or neuroplasticity, plays a pivotal role in learning and refining motor skills. When we embark on learning a new activity like playing the piano or riding a bicycle, our brain initially engages in a trial and error process. This is where the prefrontal cortex comes in, supporting attention and planning. As we repeat these movements, the cerebellum, known for its role in motor control and learning, fine-tunes these actions, ensuring fluidity and precision over time. The basal ganglia also contribute by helping automate these movements, transforming conscious effort into almost reflexive action. Imagine practicing martial arts. Initially, each punch and kick requires focused attention and deliberate execution. Over time, with consistent practice, these movements become smoother and more automatic. This transition is the brain's way of optimizing efficiency, freeing up cognitive resources for other tasks. Such automation is evident in skilled athletes, musicians, and even in daily activities like typing or brushing our teeth. This blend of neural circuitry, practice, and adaptation underscores the remarkable capability of our brain to master and perfect motor skills throughout life. Neurological disorders affecting motor function. It's astonishing how our brains, those intricate and complex masses of neurons, coordinate so many aspects of our daily lives. When everything is working seamlessly, we rarely think about the myriad processes involved in something as simple as picking up a cup of coffee or walking down the street. However, certain neurological disorders can disrupt this fine-tuned system, highlighting just how complex it all is. Some of the most common disorders that affect motor function include Parkinson's disease, multiple sclerosis, MS, amyotrophic lateral sclerosis, ALS, and cerebral palsy, CP. Parkinson's disease, for instance, is caused by the gradual loss of nerve cells in the brain that produce dopamine. Without adequate dopamine, motor functions become impaired, resulting in tremors, stiffness, and slow movements. Multiple sclerosis, on the other hand, involves the immune system attacking the protective covering of nerves, leading to communication problems between the brain and the body. This can result in a wide range of physical difficulties, such as walking problems, muscle weakness, and coordination issues. ALS, also known as Lou Gehrig's disease, leads to the death of neurons that control voluntary muscles. Patients experience progressive muscle weakness and ultimately lose the ability to move. Cerebral palsy primarily arises from brain damage, either during pregnancy or shortly after birth, leading to lifelong impacts on muscle control, coordination, and posture. Living with a neurological condition that affects motor function is incredibly challenging. Daily activities that we often take for granted become significant barriers. For instance, someone with Parkinson's may struggle with buttoning a shirt or getting out of a chair. These conditions necessitate lifestyle adjustments, sometimes requiring assistive devices. Many individuals with MS find that fatigue profoundly impacts their day, making even routine tasks feel insurmountable. For those with ALS, the progressive nature of the disease means a continuous adaptation to worsening symptoms, often resulting in the need for supportive care. Children with cerebral palsy might need physical and occupational therapy for the rest of their lives to help manage their symptoms and maintain as much independence as possible. Understanding these conditions better can foster empathy and support for those affected. Small acts of kindness, like offering help with daily tasks or simply being patient and understanding, can make a big difference. For those living with these disorders, engaging in targeted physical therapy and adaptive exercises can help maintain motor function for as long as possible. Simple exercises like gentle stretching and balance drills can be incredibly beneficial. Staying informed and connected with support groups also provides emotional and practical support. contributing significantly to quality of life. Chapter 9: Brain Development and Aging. Neuroplasticity and Brain Development. The human brain is renowned for its incredible capacity to change and adapt throughout an individual's lifespan. This phenomenon, known as neuroplasticity, refers to the brain's ability to reorganize itself by forming new neural connections. During the early stages of development, neuroplasticity is particularly potent. For instance, as children learn to walk, talk, and interact with their environment, their brains are in a constant state of flux, rapidly forming and refining neural pathways based on their experiences. Imagine watching a child learning to ride a bicycle. Initially, they might wobble and fall, but as they practice, the neural circuits in their brain responsible for balance, coordination, and motor control become more efficient and precise. This adaptive process is a real-time demonstration of neuroplasticity in action. It allows children to recover remarkably quickly from injuries, learn new languages with ease, and even develop essential life skills. In adulthood, this capacity does not disappear but becomes more task-specific, allowing us to adapt to new job roles, learn new hobbies, or recover from brain injuries. Neuroplasticity is pivotal to learning and memory. Every new experience, piece of knowledge, or skill we acquire involves the strengthening of synaptic connections between neurons. For instance, when memorizing a new piece of information, repeated exposure and rehearsal cause synapses to become more robust, facilitating better recall in the future. This adaptability extends to brain recovery as well. After a traumatic brain injury or stroke, neuroplasticity allows the brain to rewire itself, with neurons sometimes taking over the functions of damaged areas. Rehabilitation therapies leverage this plasticity to help patients regain lost abilities through targeted exercises and stimulations, encouraging the brain to form new functional pathways. As we navigate our lives, it's useful to indulge in activities that challenge the brain, like learning a new language, practicing a musical instrument, or solving puzzles. These mentally stimulating tasks harness neuroplasticity, keeping our brains agile and adaptable, better equipped to tackle the challenges of an ever-changing world. Cognitive decline and aging. As I reflect on my own experiences and those of my aging relatives, I find it fascinating yet troubling to consider how aging affects our cognitive abilities. Over time, it becomes increasingly evident that memory, attention, and problem-solving skills do not remain as sharp as they once were. This phenomenon is not merely anecdotal. Extensive research shows that as we age, our brain's structure and function undergo significant changes. For instance, the volume of the brain tends to shrink, particularly in regions such as the hippocampus, which is crucial for memory formation. This reduction in brain volume is accompanied by a decrease in the number of neural connections, impacting our ability to process and retrieve information efficiently. Diving deeper, we find that age-related neurodegenerative diseases can exacerbate these cognitive declines. Alzheimer's disease, for example, is one of the most well-known conditions affecting elderly individuals. It is characterized by the accumulation of amyloid plaques and tau tangles in the brain, which disrupt neuronal function. The consequences are profound and heartbreaking. Individuals may struggle with both short-term and long-term memory loss, impaired judgment, and a decreased capacity for language and communication. Similarly, Parkinson's disease impacts cognitive function, though it's often recognized for its hallmark motor symptoms like tremors and rigidity. Cognitive symptoms in Parkinson's include difficulty with executive functions like planning, multitasking, and problem-solving. These diseases highlight the intricate relationship between aging and cognitive decline, reminding us that maintaining brain health is just as critical as keeping our bodies fit. One useful piece of information that emerges from studying cognitive decline and aging is the benefit of an active lifestyle for brain health. Incorporating regular physical activity, mental stimulation, and social interactions into daily routines can help to slow down cognitive decline. Engaging in activities such as reading, puzzles, or learning new skills can keep the brain agile. Even maintaining strong social connections and participating in community activities can contribute significantly to preserving cognitive functions. It is reassuring to know that while aging inevitably brings changes, there are proactive steps we can take to mitigate their impact on our brains. promoting brain health and longevity. One of the most fascinating aspects of getting older is discovering ways to keep our minds sharp and vibrant. Imagine waking up each day to a brain that's as lively and inquisitive as ever. It's not only possible, but increasingly attainable, thanks to a variety of strategies and interventions aimed at maintaining brain health and cognitive function. It all begins with mental exercises that challenge the brain, much like physical exercises that strengthen muscles. Engaging in activities such as puzzles, reading, learning new skills, or even playing musical instruments can help enhance brain plasticity. We're essentially giving our brains a workout, stimulating neural pathways that might otherwise go unused. Another powerful tool at our disposal is social interaction. Staying socially active can significantly reduce the risk of cognitive decline. Whether it's engaging in meaningful conversations, participating in group activities, or volunteering, these interactions help us feel connected and mentally stimulated. Additionally, one cannot ignore the importance of sleep. Adequate, restful sleep is crucial for brain health, as it's a time when the brain consolidates memories and flushes out toxins, keeping the neural environment clean and efficient. Turning to lifestyle factors, our diet plays an extraordinary role in neuroprotection. Diets rich in antioxidants, healthy fats, vitamins, and minerals can support brain health. Foods like berries, nuts, fish, and leafy greens are known to foster neuroprotection. Additionally, physical exercise promotes the flow of oxygen-rich blood to the brain, which can support neurogenesis, the birth of new neurons. Regular physical activity, even something as simple as walking, can improve cognitive function and resilience to neural aging. Reducing chronic stress is another essential element. Chronic stress can harm areas of the brain involved in memory and learning, such as the hippocampus. Practicing mindfulness, meditation, or yoga can lower stress levels and provide a mental calmness that benefits overall brain health. Lastly, maintaining a sense of purpose through hobbies, goals, and passions is invaluable. Pursuing activities that bring joy and fulfillment contributes to mental stimulation and emotional well-being, which together foster a thriving brain well into our later years. Chapter 10: Brain Injuries and Neurological Disorders. Understanding traumatic brain injuries. Traumatic brain injuries, or TBIs, are unfortunately more common than many realize. They can happen in the blink of an eye due to causes like falls, car accidents, or sports injuries. When the head experiences a violent blow or jolt, the brain may move rapidly back and forth within the skull, leading to bruising, torn tissues, and other physical damage. These injuries can range from mild concussions to severe brain damage that can result in significant cognitive, behavioral, and physical impairments. The immediate consequences might include confusion, dizziness, headaches, and in severe cases, unconsciousness. Long-term effects are more varied and can involve persistent memory problems, changes in mood or personality, and challenges with coordination and balance. It's vital to understand that each brain injury is unique, and the impact can differ markedly from person to person. Despite the potentially devastating effects of traumatic brain injuries, the human brain's capacity for recovery and adaptation is nothing short of miraculous. Neuroplasticity, the brain's ability to reorganize itself by forming new neural connections, plays a critical role in recovery. Through therapy and rehabilitation, individuals can regain lost functions or develop alternative strategies to cope with their new limitations. Physical therapy can help rebuild strength and coordination, while occupational therapy focuses on improving daily living skills. Cognitive therapy, on the other hand, can aid in restoring memory and problem-solving capabilities. Emotional and psychological support is equally important, as dealing with the aftermath of a TBI can be mentally and emotionally taxing. Advances in medical research continue to provide new insights and innovative treatments, offering hope for more effective recovery options. One of the most empowering aspects of dealing with a traumatic brain injury is understanding the potential for improvement and adaptation. Building a strong support network, including healthcare professionals, family, and friends, can make a significant difference in the rehabilitation process. Staying informed about the latest research and available therapies can also provide valuable tools for managing the journey ahead. By fostering a positive mindset and leveraging the brain's inherent abilities, Many individuals not only recover, but also lead fulfilling lives post-injury. Each small step forward is a testament to the brain's resilience and the human spirit's determination. Neurodegenerative disorders. I have always found neurodegenerative disorders both terrifying and fascinating. These are the diseases that lead to the progressive loss of brain function, an inevitability that is as relentless as it is tragic. Picture a charming garden slowly overtaken by weeds, meticulously cultivated paths becoming concealed, beloved flower beds buried beneath a creeping blanket of entropy. Alzheimer's disease, Parkinson's disease, and amyotrophic lateral sclerosis, ALS, are among the most notorious villains in this narrative. They unspool the very fabric of who we are by steadily eroding memory, cognition, and physical abilities. Alzheimer's disease, the most common form of dementia, gradually robs individuals of their memories and thinking skills until they can no longer carry out the simplest tasks. Plaques and tangles, abnormal structures in the brain, become tombstones marking the demise of neurons. Equally chilling is Parkinson's disease, where the decline in dopamine production leads to tremors, rigidity, and impaired movement. One of the most haunting experiences is encountering someone with ALS. Known as Lou Gehrig's disease, it cruelly paralyzes its victims while leaving their minds frighteningly intact, a profound and heartbreaking contrast. The race to understand these disorders is a global endeavor, with researchers dedicating countless hours and resources to uncover their mysteries. I recently read about a fascinating approach using stem cell therapy. The potential to regenerate damaged neurons could be revolutionary, but as with any pioneering treatment, it comes with its own set of ethical and scientific challenges. Another exciting avenue is the use of biomarkers in diagnostics. Being able to identify these diseases years before symptoms manifest could lead to early interventions that might slow or even halt the progression. Medication options are currently a mixed bag. While some drugs can manage symptoms or even temporarily improve them, they often fall short of halting the inexorable march of these diseases. However, the development of new drugs targeting specific protein abnormalities presents a glimmer of hope. There is also a burgeoning interest in the gut-brain axis, the idea that gut microbiota could influence neurodegeneration. It adds a layer of complexity but also possibility, suggesting that dietary changes or probiotics might one day become part of a treatment regimen. While science progresses, there's still much to understand about these devastating conditions. If there's one practical tip I've gleaned from all this, it's to stay mentally and physically active. Activities like reading, exercise, and social engagement can help maintain cognitive function and offer a buffer against the encroaching darkness. We may not have all the answers now, but every piece of knowledge brings us a step closer to vanquishing these silent enemies. Mental health disorders and the brain. Mental health disorders often elicit reactions that feel incredibly personal and lived in, yet they are deeply intertwined with brain functions. It's fascinating to consider how something as intangible as our thoughts and feelings is rooted in the physical structure of the brain. Disorders like depression, anxiety, and schizophrenia are not merely abstract afflictions. They have concrete biological underpinnings. For instance, depression has been linked to imbalances in neurotransmitters such as serotonin and dopamine, the chemicals that carry signals between neurons. These imbalances can disrupt communication within the brain, leading to the emotional and physical symptoms that define the disorder. Anxiety disorders also showcase the brain's involvement. The amygdala, a small almond-shaped region, is known to be hyperactive in individuals with anxiety. This part of the brain is responsible for processing fear, and its overactivity can lead to an exaggerated response to stressors. Schizophrenia, a more severe mental health condition, involves intricate disruptions in brain function. Research indicates abnormalities in the prefrontal cortex, a region associated with decision-making and behavior regulation, and imbalanced neurotransmitter levels, particularly dopamine. Understanding the brain's role in mental health disorders is crucial for developing effective treatments. Treatment approaches often start with pharmacotherapy, targeting the chemical imbalances. Antidepressants, like SSRIs, work by increasing serotonin levels in the brain, thus improving mood and emotion regulation. Antipsychotics for schizophrenia help in balancing dopamine levels, tackling symptoms such as hallucinations and delusions. Beyond medications, neural mechanisms offer insights into alternative treatments. Cognitive behavioral therapy, CBT, is a powerful tool that leverages our understanding of neural plasticity, the brain's ability to reorganize itself by forming new neural connections. Through CBT, patients learn to reshape their thought patterns, which can physically alter brain function over time. Emerging treatments like neural stimulation techniques, for example, transcranial magnetic stimulation, TMS, directly influence brain activity, showing promise in cases where traditional treatments fall short. Mental health disorders and their treatment underscore how intricately our minds and brains are linked. They reveal that mental health is not just about thoughts and feelings in isolation, but also about the physical and chemical processes in our brains. Recognizing this connection opens up numerous avenues for understanding and addressing these challenges, offering hope and practical solutions to those affected. Chapter 11: Brain Imaging and Research Methods. Advances in brain imaging techniques. We're living in an exciting era where brain imaging technologies are advancing at breakneck speeds, opening new horizons in neuroscience research. Imagine being able to peer inside the brain in real time, understanding how neurons communicate, and even predicting how certain diseases progress. Technologies like functional magnetic resonance imaging, fMRI, and positron emission tomography, PET, have revolutionized our capabilities, allowing us to visualize brain activity and metabolic processes with incredible precision. Techniques such as diffusion tensor imaging, DTI, provide detailed maps of neural pathways, making it possible to examine the brain's intricate wiring. This has immeasurably advanced our understanding of cognitive functions, mental illnesses, and neurodegenerative diseases. Each brain imaging modality brings unique strengths and limitations to the table. Take fMRI, for example, which measures brain activity by detecting changes in blood flow. While it's non-invasive and provides excellent spatial resolution, its temporal resolution is limited, meaning it can't track the brain's activity in real time. On the other hand, electroencephalography, EEG, offers high temporal resolution but has poor spatial resolution. PET scans are highly sensitive and can image biochemical changes within the brain. However, they expose subjects to radioactive tracers, limiting their frequency of use. Magnetoencephalography, bridges some gaps by offering good spatial and temporal resolution, but requires expensive, specialized equipment, making it less accessible for many research facilities. Understanding these trade-offs is crucial for selecting the right imaging technique for specific research questions and clinical applications. Practically speaking, one often uses a combination of methods to get a fuller picture of brain function. The key takeaway here is knowing the strengths and weaknesses of each modality to make informed decisions that advance both basic neuroscience and clinical practice. Modern approaches to studying the brain. Emerging technologies have revolutionized how researchers peer into the enigmatic world of the brain, one of the most complex biological structures. Techniques like functional magnetic resonance imaging, fMRI, allow us to visualize brain activity in real time, revealing which regions light up during specific tasks or emotions. Alongside fMRI, there's magnetoencephalography, MEG, which measures the magnetic fields produced by neuronal activity. This non-invasive method provides a window into the brain's electrical currents, offering insights into how different regions communicate and synchronize. Advances in genetics and molecular biology have enriched our understanding of the brain's development and functioning. Single-cell RNA sequencing enables scientists to examine gene expression in individual neurons, which helps decode the molecular signatures of various brain cells. Through optogenetics, researchers can control neuronal activity using light, providing an intricate control over specific circuits and behaviors. Such precise techniques are essential for unraveling the brain's vast network and can even pave the way for novel treatments for neurological disorders. Interdisciplinary approaches bring together diverse fields like neuroscience, psychology, artificial intelligence, and bioengineering to tackle the brain's mysteries. The convergence of AI and neuroscience has led to machine learning models that can predict neurological conditions and simulate brain function. AI-driven reconstruction of neural pathways offers a deeper understanding of brain networks and their connectivity. Additionally, collaborative efforts between bioengineers and neuroscientists have produced advanced neuroprosthetics, devices that can restore lost sensory and motor functions through direct brain-machine interfaces. Emerging fields like neuroethics and neuroaesthetics push the boundaries of brain research, contemplating the ethical implications of brain modification technologies and exploring how the brain perceives and creates art. These fields encourage us to think critically about the impact of our expanding knowledge on society while enhancing our appreciation for the brain's role in human culture and consciousness. Keeping abreast of these modern approaches not only informs us about brain function, but also challenges us to continually rethink our understanding of the mind. Ethical considerations in brain research. Embarking on brain research offers us an unparalleled glimpse into the complexities of the human mind. This field, though brimming with potential, is riddled with ethical quandaries that demand careful consideration. For instance, when we dive into understanding neural mechanisms, the privacy of individuals becomes paramount. Imagine the scenarios where brain imaging techniques could inadvertently reveal personal information, such as susceptibility to certain mental conditions or cognitive abilities. Safeguarding this data is crucial to maintaining trust and dignity. We must tread carefully, balancing the advancement of science with the respect for personal autonomy and confidentiality. Working with human participants brings its own set of responsibilities. Informed consent is not just a formality, it is the cornerstone of ethical research. Participants need to fully understand the nature, risks, and benefits of the study, ensuring they are not just subjects, but active, willing contributors. Engaging in transparent communication helps diminish the power imbalance often present in research settings. When research involves animal subjects, our ethical obligations extend to ensuring humane treatment. The principle of the 3 R's, replacement, reduction, and refinement, guides us to seek alternatives, minimize the number of animals used, and refine procedures to alleviate or eliminate distress. Trust plays a pivotal role in conducting brain research responsibly. From adhering to established ethical guidelines to fostering a culture of transparency and accountability, researchers must make ethical conduct an intrinsic part of their practice. It is essential to continually reassess and update ethical standards to keep pace with technological and scientific advancements. Sharing findings with the broader community openly and responsibly not only propels the field forward, but also honors the contributions of participants and respects the ethical commitments we have undertaken. One practical tip for those engaged in brain research: always prioritize open dialogue. Whether it is with your colleagues, participants, or the public, fostering an environment where ethical considerations are openly discussed can pave the way for more responsible and impactful research. This approach not only enhances scientific integrity, but also ensures that our quest to understand the brain is conducted with the utmost respect for all involved. Chapter 12: The Brain and Behavior, Neurobiology of Decision-Making. When I first started delving into the neurobiology of decision-making, I was fascinated by how our brains orchestrate the complex process of choosing one option over another. It all begins in the prefrontal cortex, a region critical for higher-order cognitive functions. This part of the brain integrates information from various other areas, enabling us to weigh the pros and cons of different choices. The ventromedial prefrontal cortex, in particular, is essential for evaluating the value of different options, while the dorsolateral prefrontal cortex helps with planning and inhibition, which means sometimes resisting that tempting slice of cake when you're on a diet. Neurotransmitters like dopamine play a significant role too. Dopamine is often dubbed the feel-good neurotransmitter, but it does more than just make us feel pleasure. It encodes the value of potential rewards and helps us anticipate which choices might lead to more rewarding outcomes. Imagine you're faced with choosing between 2 job offers. One offers more money, the other work-life balance. Your brain circuits involving dopamine will help you assess the rewards associated with each option, making your final decision more informed and aligned with your preferences and priorities. Factors such as past experiences and learning also shape our decision-making processes. The more information our brains can draw from, the better equipped we are to make sound choices. As we navigate through various decisions, cognitive processes such as reasoning and problem solving come into play. However, emotions are intertwined with these processes, sometimes enhancing and other times hindering our decision making capabilities. Think about the last time you made a hasty decision out of anger or excitement. Emotional arousal can influence our preferences and judgments, occasionally leading us astray. Additionally, cognitive biases, those pesky mental shortcuts our brains take to save time and energy, often skew our decisions. Confirmation bias, for instance, makes us favor information that confirms pre-existing beliefs, while the availability heuristic leads us to overestimate the importance of information that's readily available. One practical tip is to become more aware of these biases and emotional influences. By consciously acknowledging them, we can strive to counterbalance their effects and make decisions that are more rational and less emotionally charged. The next time you're faced with an important decision, take a moment to dissect your thought process. Are you rushing because of an emotional impulse? Are you selectively focusing on information that supports your initial preference? Breaking down these complexities can help you approach decision-making with greater clarity and balance. The role of the brain in addiction. Investigating the neural basis of addiction opens up a profound understanding of how deeply intertwined our brains are with our habits and desires. The brain is an intricate network of neurons that communicate through chemical and electrical signals. When we consume addictive substances, they hijack the brain's communication pathways. Essentially, drugs like cocaine, methamphetamine, and opioids flood the brain with dopamine, a neurotransmitter responsible for pleasure and reward. This dopamine surge reinforces the act of drug consumption, making it feel immensely rewarding and encouraging repetition of the behavior. The brain's reward system becomes wired to prioritize the drug over other life-sustaining activities, leading to compulsive behavior. The prefrontal cortex, responsible for decision-making and impulse control, becomes impaired in addicted individuals. This impairment weakens a person's ability to assess risks, control urges, and make sound decisions. Over time, the brain's structure and function are significantly altered. The gray matter in areas responsible for judgment, memory, and behavior control can shrink. Chronic drug use effectively rewires the brain, creating a powerful and persistent craving that is challenging to overcome. The development and maintenance of addictive behaviors are influenced by a complex interplay of factors beyond the neural imbalances induced by drug use. Genetics play a considerable role, as individuals with a family history of addiction are more prone to developing similar patterns. Environmental factors such as exposure to drug use at a young age, traumatic experiences, and high stress levels also contribute. Psychological elements, such as co-occurring mental health disorders like depression and anxiety, can make individuals more susceptible. Social connections and peer pressure are crucial too. The desire to fit in or cope with social anxiety can drive individuals towards substance use. It's essential to recognize that breaking the cycle of addiction is not just about willpower. It involves understanding the multifaceted nature of the disorder and addressing it from multiple angles. By acknowledging and addressing the powerful grip the brain's adaptations have on an individual, and by creating supportive environments and comprehensive treatment approaches, recovery becomes more attainable and sustainable. Neurological basis of personality traits. Personality traits have fascinated humans for centuries, enticing us to ponder what makes each individual unique. Uncovering the neurobiological foundations of these traits, we must delve into the intricate web of neurons, neurotransmitters, and brain regions that contribute to our behavior and character. The human brain, a marvel of evolution, consists of various parts, each with specialized functions crucial to defining personality. Take the prefrontal cortex, for instance. It is responsible for executive functions, decision-making, and impulse control. When individuals exhibit traits like conscientiousness, it is this part of the brain that often comes into play, demonstrating higher activity levels. Alternatively, the amygdala, pivotal in processing emotions, fear, and pleasure, influences traits like neuroticism. Overactivity in this almond-shaped cluster of nuclei can lead to heightened anxiety and emotional reactivity, often seen in neurotic individuals. Exploring the interplay between genetics, environment, and brain structure reveals a rich tapestry that shapes personality. Twin studies have provided invaluable insight, suggesting that genetics contribute significantly to personality traits. However, they are not the sole players. Environmental factors, such as upbringing, culture, and personal experiences, interact with our genetic blueprint to mold our character. The brain's plasticity allows it to adapt to environmental influences, making it a dynamic organ that evolves over time. For example, long-term stress can alter brain structure, impacting areas like the hippocampus, which is involved in memory and emotional regulation, thereby affecting personality. Furthermore, the neurotransmitter systems, including serotonin and dopamine pathways, play vital roles. Serotonin's influence on mood and behavior is well documented, with lower levels often linked to higher neuroticism. Dopamine, involved in reward processing and motivation, correlates with extroversion and openness to experience, illustrating the biochemical underpinnings of our traits. Chapter 13: The Brain in Popular Culture. Portrayal of the brain in media. The brain often takes center stage in popular culture, depicted as a miraculous machine capable of brilliance beyond our wildest dreams, or, conversely, a biological computer susceptible to trivial glitches and catastrophic failures. Movies, TV shows, and even news headlines present a wide range of portrayals. Sometimes it's the genius scientist whose brain operates on a level far above the norm, providing them capabilities that seem almost superhuman. Other times, it's the sinister manipulation of the brain, like the mind control scenarios often seen in thrillers. Such portrayals can be entertaining but tend to simplify the brain's true complexity, leading to misunderstandings among the general audience. Media representations often make it seem like the brain is a set piece that can be fixed or enhanced easily, like upgrading a computer program. Shows featuring sudden epiphanies, followed by monumental changes in behavior, give a skewed sense of how learning and personality actually work. More damaging are the depictions of mental illness and brain injuries, which are frequently portrayed inaccurately. Conditions like depression, schizophrenia, and PTSD are often sensationalized, contributing to stigma and misinformation. The oversimplified and sometimes melodramatic portrayals can obscure the genuine experiences of individuals dealing with these issues, affecting public perception and policy decisions. Our understanding of the brain is often shaped by what we see and hear in the media. When we see a genius prodigy solving complex problems with ease, or a villain manipulating minds, it influences how we think about human potential and ethical boundaries. These portrayals can create unrealistic expectations and fears. For example, the idea that we use only 10% of our brains continues to persist, despite being debunked by neuroscientists. This misconception has been exacerbated by movies and books, reinforcing a narrative that leaves the public misinformed. Accurate knowledge about the brain's capabilities and limitations helps us appreciate its true potential and seize realistic opportunities for growth and healing. Neuroscience and entertainment. Imagine watching your favorite movie and feeling as though you're actually living it. That intense connection isn't just good storytelling, it's the deliberate application of neuroscience. By studying how our brains respond to different stimuli, creators can craft scenes that evoke specific emotions, making the experience more immersive. For instance, understanding the brain's reaction to music allows filmmakers to use soundtracks that enhance the emotional depth of a scene, creating a more engaging experience for the audience. Advances in functional MRI, fMRI scans reveal which areas of the brain are activated by certain visual and audio cues, guiding directors in making choices that resonate more deeply with viewers. These tools not only captivate audiences but also have potential benefits. By leveraging the principles of neuroplasticity, the brain's ability to change and adapt, entertainment can be a platform for mental health interventions. Video games designed with cognitive behavioral principles can help manage anxiety and depression, offering a fun and interactive form of therapy. However, there's a flip side. The ethical implications of using neuroscience are significant. One concern is the potential for manipulation. If creators can tap into our psyche so effectively, they also hold the power to influence our thoughts, behaviors, and decisions. Balancing the benefits with ethical considerations is crucial for the responsible use of these powerful tools. For creators and consumers alike, staying informed about how our brains interact with entertainment is important. Recognizing the techniques used can make us more discerning viewers, allowing us to appreciate the craft while being mindful of the psychological influences at play. As technology and research continue to evolve, the line between reality and fiction will blur even further, offering both incredible opportunities and complex challenges in how we engage with entertainment. Public perceptions of brain science. The perception of brain science affects how people engage with research and healthcare. Many individuals have a mix of fascination and apprehension when it comes to understanding the complexities of the brain. This blend of emotions is often fueled by misconceptions that persist despite advances in neuroscience. For instance, a common belief is that humans only use 10% of their brain, a myth that has been debunked but still lingers in public consciousness. Such myths can distort how people perceive brain capabilities and limitations, impacting everything from educational approaches to healthcare decisions. Addressing these misconceptions requires not just correcting false beliefs, but also fostering a deeper, more nuanced understanding. Effective science communication is crucial. One strategy is using relatable analogies that simplify complex concepts without oversimplifying the science. For example, comparing the brain's network of neurons to a city's roadways can make the idea of neural pathways more accessible. Engaging storytelling can also transform abstract data into memorable narratives. Another important approach is transparency in research reporting, making sure that findings are communicated clearly and accurately to avoid misunderstandings or sensationalism. In addition, community engagement can play a pivotal role. Events like public lectures, interactive exhibits in science museums, and educational programs in schools can make brain science more approachable and fascinating. Online platforms and social media can further bridge the gap, offering interactive content like webinars and Q&A sessions with neuroscientists. By integrating these strategies, we can promote a more accurate and appreciative understanding of the brain, helping dispel myths and fostering a culture that values scientific literacy. Chapter 14: Future Directions in Brain Research, Emerging Technologies in Neuroscience. Innovative technologies and methodologies are revolutionizing brain research, pushing the boundaries of what we once thought possible. One of the most groundbreaking tools in this realm is functional magnetic resonance imaging, fMRI. With fMRI, we can observe brain activity in real time, providing stunning insights into how different regions interact during various cognitive tasks. Alongside fMRI, advancements in optogenetics allow us to control and monitor the activity of individual neurons using light, enabling unprecedented precision in the study of neural circuits. Another significant leap comes from developments in neuroinformatics, which merges data from numerous studies into comprehensive databases. This integration facilitates new discoveries by allowing researchers to analyze large-scale data and draw connections that were previously obscured. Additionally, machine learning algorithms are becoming indispensable, as they can detect patterns in complex datasets, offering new hypotheses about brain function and pathology. Notably, brain-computer interfaces, BCIs, are extending our capabilities not only to study the brain, but to communicate directly with it. BCIs hold the promise of assisting patients with movement disorders or severe paralysis, potentially restoring lost functions. These advancements are expanding our understanding of the brain in extraordinary ways. For instance, studying brain plasticity with advanced imaging techniques reveals how the brain reorganizes itself in response to injury or learning. This knowledge opens up new therapeutic avenues for stroke victims and individuals with neurodegenerative diseases. Breakthroughs in connectomics, which map the brain's intricate network of neurons, provide deeper insights into how various regions coordinate to influence behavior and cognition. Understanding these connections can lead to more effective treatments for mental health conditions such as depression and anxiety. Moreover, insights gleaned from neurotech innovations help in decoding the neural basis of consciousness, offering a better grasp of what makes us uniquely human. We can now explore how thought processes and emotions arise from neural activities, helping us understand not only normal brain function, but also the underpinnings of neurological disorders. As we delve further, the potential for personalized medicine becomes more tangible. Tailoring treatments based on individual neurobiological profiles can lead to more effective and targeted therapies, improving outcomes and reducing side effects. Ethical and societal implications of brain advancements. Through my journey in understanding brain advancements, I have encountered a mosaic of ethical dilemmas and societal implications that are as intricate as the neural networks themselves. On one hand, the breakthroughs in brain research hold promises of curing neurodegenerative diseases, enhancing cognitive functions, and even drastically improving mental health treatments. However, these advancements come hand in hand with ethical concerns about privacy, autonomy, and the essence of human identity. For instance, brain-computer interfaces, BCIs, have the potential to revolutionize how we interact with technology, yet they also present risks of unauthorized access to our thoughts and emotions. Reflecting on these scenarios, I can't help but think about how society will grapple with the potential for misuse, such as neurohacking or the manipulation of cognitive processes for malicious purposes. The future of neuroscience hinges not just on the technological possibilities, but also on our ability to navigate these profound ethical landscapes intelligently and compassionately. In conversations with experts, the notion of mind-reading technologies often surfaces, sparking debates on consent and the extent of surveillance that might be deemed acceptable. If our innermost thoughts can be decoded and read, what privacy remains? What safeguards must we put in place to ensure that such technologies enhance our lives without encroaching upon our most personal domains? Envisioning a society where brain data could be commodified and sold like browsing history unsettles me. Consequently, establishing robust ethical frameworks and regulatory policies becomes paramount. We need interdisciplinary dialogues that include neuroscientists, ethicists, policymakers, and the public to outline rights, limitations, and responsibilities. Only then can we ensure that the values of human dignity and freedom remain upheld amidst the rapid pace of technological innovation. As I delve deeper into the practical applications of technological advancements in neuroscience, I am acutely aware of the need for responsible use that is both equitable and inclusive. Take, for example, the growing field of neuroenhancement. From cognitive enhancers that might improve memory and attention to neural implants providing superior mental processing, the possibilities are mind-boggling. However, these benefits must be accessible to all, and not just a privileged few. Else we risk deepening social inequities. I often ponder on how we can ensure that the fruits of brain research are distributed fairly and not exacerbate existing societal divides. It is essential to foster innovation ecosystems that promote inclusivity, where marginalized and underserved communities have the same opportunities to benefit from these advancements. The role of education and public engagement cannot be overstated in this context. Informing the public about the potentials and pitfalls of brain technologies empowers them to make informed choices and advocate for policies that reflect collective values. Moreover, involving diverse groups in the research and development process can provide insights into varied needs and ethical considerations, ultimately leading to more holistic and equitable solutions. Imagine if we could harness the collective intelligence and experiences of global communities to address the ethical and societal challenges posed by brain advancements. That would indeed mark a progressive stride towards an equitable future in neuroscience. The quest for understanding consciousness. Consciousness has always been one of the most profound and mystifying aspects of our existence. It's the essence of our being, what makes us aware of ourselves and the world around us. Yet, despite centuries of philosophical debates and scientific inquiries, the enigma of consciousness remains largely unsolved. I remember feeling a sense of awe the first time I seriously contemplated the nature of my own consciousness. Our self-awareness, subjective experiences, and the ability to think and feel in such a deeply personal way all seem like miracles that science has yet to fully explain. Scientists, philosophers, and neuroscientists have been on an ongoing quest to unravel the mysteries of consciousness, employing ever more sophisticated tools and theories. Brain imaging technologies, cognitive psychology, and even computational models have advanced our understanding, but the core puzzle remains elusive. Each discovery seems to reveal another layer of complexity, drawing us deeper into the quest. Various theories have been proposed to explain consciousness, each shedding light on different facets of this profound phenomenon. Theories range from the dualism of René Descartes, which posits that the mind and body are separate entities, to more contemporary approaches like integrated information theory, IIT, and the global workspace theory. IIT suggests that consciousness is a byproduct of the brain's ability to process information integratively. The more information a system can integrate, the more conscious it becomes. On the other hand, the global workspace theory implies that consciousness arises when information is broadcasted to different parts of the brain, allowing for global processing and coordination. I found myself particularly fascinated by these theories, as each offers a unique lens through which we can explore our inner worlds. The complexity and elegance of the brain's wiring, the electrical impulses zipping through neural pathways, all working together to create the seamless experience of being aware. It's nothing short of extraordinary. The great allure of studying consciousness lies not just in the potential scientific breakthroughs, but in the deeper understanding of what it means to be human. This pursuit invites us to ponder age-old questions and equips us with modern tools to explore them. For anyone fascinated by the nature of self-awareness, delving into the study of consciousness is like embarking on a grand adventure where each discovery opens the door to yet more intriguing questions. It's a relentless journey, but one that continually enriches our understanding of ourselves at the most fundamental level. Chapter 15: Practical Applications of Brain Knowledge, Neuroscience in Education. The intersection of neuroscience and education offers fascinating insights that could revolutionize how we understand and improve educational practices. By delving into brain functions, we uncover how students process information, form memories, and develop skills. Imagine understanding why a student struggles with reading comprehension while another excels in math without the traditional trial and error methods. Neuroscience allows us to get to the core of these learning differences. For instance, research on neuroplasticity reveals how the brain reorganizes itself by forming new neural connections throughout life. This means educational interventions can be designed to strengthen these pathways, making learning more efficient and personalized. The potential of these insights extends beyond just understanding learning deficiencies. By knowing how the brain acquires and retains information, educators can develop innovative teaching strategies that align with these processes. One significant application is the concept of spaced repetition, rooted in how our brains consolidate memories over time. Instead of cramming, which often leads to quick forgetting, lessons can be spaced out to reinforce learning continuously. Additionally, integrating multisensory techniques can cater to diverse learning styles, ensuring that auditory, visual, and kinesthetic learners all have the opportunity to thrive. Guest speakers from the field of neuroscience can also bring firsthand knowledge, making abstract concepts tangible for students. An exciting frontier is the use of brain imaging technologies, such as fMRI and EEG, in classrooms. These tools can identify areas of the brain activated during specific tasks, offering real-time feedback on student engagement and comprehension. For example, if a particular teaching method consistently activates regions associated with deep learning and understanding, it suggests efficacy and can be adopted more widely. Moreover, neurofeedback can be employed to help students with attention disorders by training them to maintain focus through visual and auditory cues. Essentially, the classroom transforms into a dynamic environment where learning is continuously optimized based on direct brain responses. Brain-computer interfaces. Imagine a world where you can control devices and communicate with others just by thinking. This isn't the stuff of science fiction anymore. It's the rapidly evolving field of brain-computer interfaces, or BCIs. These systems establish a direct communication pathway between the brain and an external device, opening up possibilities that are astoundingly futuristic. Technological advancements in neuroscience and computer engineering have paved the way for BCIs to move beyond laboratories and into everyday applications. Whether it's for medical rehabilitation, gaming, communication, or even artistic expression, BCIs hold the potential to transform how we interact with the world around us. Through the marvel of neurotechnology, brain signals are harnessed to control external devices, effectively transforming thoughts into actions. This is accomplished by detecting neural activity, often through electroencephalography, EEG, or other non-invasive methods, and translating these signals into commands that machines can interpret. In medical contexts, BCIs offer incredible promise in assistive technologies for individuals with physical disabilities, enabling them to operate wheelchairs, communicate through computer interfaces, or even regain some degree of limb movement through neuroprostheses. The applications extend to enhancing cognitive capabilities and providing new methods for individuals to interact with complex systems like drones or robotic arms. Brain health and wellness practices. Maintaining brain health is about adopting certain lifestyle factors and interventions that can have a big impact. From my experience, daily habits play a crucial role. A balanced diet rich in omega-3 fatty acids, antioxidants, and vitamins supports brain health immensely. Foods such as fish, nuts, berries, and leafy greens should be a part of your daily consumption. Regular physical activity also contributes significantly. Activities like walking, swimming, and yoga help increase blood flow to the brain, which in turn enhances its function. Another important aspect is mental stimulation. Engaging in activities that challenge your brain, like puzzles, reading, or learning new skills, keeps your cognitive functions sharp. Stress management is also crucial. Techniques such as mindfulness meditation, deep breathing exercises, and maintaining a good sleep schedule can decrease stress and improve brain health. Social connections are equally important. Engaging in meaningful interactions with friends and family helps keep the brain healthy and reduces the risk of cognitive decline. Research has shown that maintaining cognitive vitality as we age is achievable through consistent efforts. Neuroplasticity, the brain's ability to reorganize itself by forming new neural connections, is a critical factor. Engaging in lifelong learning and new experiences helps stimulate this plasticity. Studies suggest that people who continue to learn and explore new things maintain better cognitive functions over time. Furthermore, staying physically active is linked to the production of neurotrophic factors, which promote the growth and survival of neurons. Preventing age-related cognitive decline also involves monitoring cardiovascular health. Conditions like hypertension, diabetes, and high cholesterol can negatively impact brain health. Therefore, keeping these conditions in check through regular medical checkups and a healthy lifestyle is essential. Sleep quality is another significant factor. Poor sleep can lead to impaired memory and cognitive function, so ensuring you get enough rest is a must. Aiming for 7 to 9 hours of sleep per night can make a world of difference. Embrace activities that combine physical, mental, and social engagement. Gardening, dance classes, or volunteer work can provide a fulfilling mix of these elements. Additionally, staying curious and open to new technology and innovations keeps the mind agile. Remember, integrating these practices into daily life creates a foundation for long-term brain health and cognitive vitality, allowing us to enjoy a sharper mind well into our later years. Thank you for exploring the wonders of the human brain with us in The Human Brain, Understanding How Our Brain Works. We hope this book has provided valuable insights into the incredible workings of your brain and has sparked a deeper curiosity about the field of neuroscience. Remember, the more we understand about our brain, the better equipped we are to harness its potential and improve our overall well-being. Keep exploring, stay curious, and continue to appreciate the marvels of your mind.